Welcome back. The CodinGame Winter Challenge 2024. So right now we're still in silver using this code that we basically optimized for the wood leagues, so it's a bit different now. So yeah, I don't like a lot of stuff. We need to start thinking about more of a approach where you so we need to think about overall objectives, like not moving one step left, move one step up, move one step right, whatever, but overall objectives like capture C, capture D, and so on. Which one of those higher level objectives to go for. So right now, what are the sort of things we can do? Ignore sporing for now. Just focus on one organism. The idea is so we either grow a the objectives we're going for are either we grow a harvester or grow a tentacle, essentially. The basic just happens to be something we do as a bridge to doing those things. Or at least well, no. If all else fails, if we've got nothing else to do, we actually just put basics in random places, I suppose. So that's an objective as well. Place a basic. So those are the three core basics. Ignore sporers for now, because that's complicated. We have an organism. we want to do one of three things. We want to harvest a protein. So let's look at this table again. So what are good proteins to have? A is good to have because it makes basic. C and D make harvesters. B and C make tentacles. So C is a very good one. So we do kind of want... We want to know what our income is. We want to know what our current protein count is, and that will influence what proteins we want to go for. Like, in the early game, you would want more C and D, C especially. In the late game, you might want more A, although you always need more A, so... So a nice simple thing would be try to keep find whatever our worst protein is and try to increase that. We do always need A though, so A is quite important. We should also evaluate whether we can afford the full chain of organs to get to a place, because there's no point going for a place if we can't afford it. So we choose... Oh, so there's a lot to think about here. So we need a method, really, that just evaluates all possible proteins we could go for, works out the cost in both proteins to get there, and also time, because time matters. Although, we might care more about minimizing the protein cost, I don't know. We still want to make sure time... What's the time limit? I mean... We can not worry about the time limit for now, because 100 turns is the time limit, so... In the last few turns, we might reevaluate based on the fact that we have like a limited time to actually get to things, but... There's so much to think about. So yeah, we want to... Okay, so I mentioned a couple of things we can make methods for. One is we need to... Okay. This protein thing, maybe we should think of this as a vector that we can... It'll be easier to deal with. So... Protein should really be a vector, like with 4 integers, and that will let us see if one vector is greater than another, as in you have enough protein to do something. So let's say we've got a protein. So it simply has A, B, C, D, and we've got some of these methods, I suppose. We want subtraction, yeah, equality, hash. Take those. Add itself dot A, other dot A, Y plus other dot Y. What B? All these letters wrong. Self.c, self.p. All right. So that lets us handle proteins better. Suppose we're gonna have to change a whole bunch of things now. Distance. We can have distance. It would basically be the Hamming distance, because that will reflect how many individual proteins you have to get from one vector to the other. I think that might be useful. Not sure if we'll use it, but there's that. You can have absolute value as well. So this will be, well, no, don't call it abs, call it norm. This will be return self.dist with protein 0000. Total number of proteins in this whole vector. gotta change everything. So this do actions thing, we might not be using this anymore. Let's just comment everything out for now. So we're just waiting. Now, proteins. These are setup positions where proteins are located. I suppose that's useful. My proteins is going to be not this anymore. It'll be that. Enemy proteins will be that. So my proteins will be wait, so how are we populating the proteins again? We're just getting them from this here. Game.myProteins equals protein B, C, D. Okay, that looks cleaner as well. Also, can we just change this to my protein, enemy protein? Well, 0 makes sense here. Or should we just make a static method here? Call it 0. So it's more contextual. It's clear that we mean this to be just the 0 vector. There we go. Okay, make sure that's all fine. So when we put proteins in the grid, we want to actually put the So how does it work again? It's this will be the harvester source. You get one of something per turn. But if you grow a basic over a protein source, you get what, 3? Yeah. Okay. So the idea is now, instead of putting proteins on the map, putting letters on the map, we're actually doing this properly, and we're saying it's a wall, if it's this, then grid.set. So what we actually want is basically, we want a method like protein dot from car. So it's like get the relevant protein from the letter, just so that we don't have to keep typing if A this, B, if B this, if C this. So we want to basically make something like it's gonna be from car. So be like A goes to protein 1000, like that basically. I mean, can we not? No, it doesn't matter. Yeah, this is fine. So we return that. Put index on the car. We move these onto new lines just so it's not so like that. Okay. Okay. Can't do that. No, you can't do that. Alright, whatever. It's probably gonna break some things. Yeah, okay. On car type. So we put that in the grid. Proteins. Right. Okay, and then rented out. So where else were we doing stuff? In the BFS. So BFS. Alright, so another thing we need is walkable, is growable in the grid. Because we need that method. Fine. Is growable. So it's going to be self.get pos is none, or is instance protein. So it's none or it's a protein. That means we can grow that. And then BFS, okay, so saying if self dot is growable neighbor here. Alright, and next, so that's that. What else did I want to do? I wanted to... We might need an organism class. So... Organ root ID. Okay, so if we're given organ root ID, we want to create a class, an organism instance for that root ID. Why are we doing this? So that we can identify an organism and which organs belong to it, and maybe some other things. Oh, because you've got the tree structure as well. You might want to do something with that. Work out which branches and what parents they have, so on. Say, so we don't want my organs, we actually want my organisms. So now it could just be a list, but we might actually want to store it as a like a tree or something. we've got a root ID int. So we don't store root ID for organ anymore. Why do we need it? You wouldn't. You would want to know which organism an organ belongs to, though. So you would want a reference to the organism. Yeah, so you would want... Oh, it's not defined a... No, they can't be... You can't have circular reliance here. Oh, whatever. Just, say any, I don't know. Organism, so it has a root ID, it has organs, the list, and anything else? Maybe, okay, let's change this. We don't actually... We'll go back to root ID. I think this gets... There's some circular issues here. Right, so here, an organism has a root ID. It has a root, I suppose. And... organs. So here we want my organisms. A list of organisms. Well, it should be a... a tick, so we want to look things up by the root ID. The only thing you need to define is... suppose this should actually be a dict as well, so we can look things up by IDs. Everything should be indexed, so we can look things up all the time. So we don't actually need to store a root, like you can get that from the dict. That's how you define an organism. All this stuff is fine. Alright, so when we populate this stuff, organ, so we create an organ. As we did before. We put the organ in the grid, that's fine. But we don't put it in we don't create a list of organs, we create a list of organisms. Alright, so. Organisms. Let's just make sure we're referring to the correct thing here. Alright. If organ root ID is not already in this list, then we want to organism is a hard word to type. Right, we want to put it in. So create a new organism on that root ID. Alright. And now it exists. So we say that it's the organism. Organs. So that's the dictionary. Organ ID equals organ. So we're putting the organ into the organism. If type is root and owner is 0, roots.append. Yeah, okay. Well, now we want to use one action per organism. So for we'll say we don't need this now. We have all our root IDs in the organisms. So for basically or organism in game.myOrganisms dot values. Do that. Don't need this one. Okay, so that's all cleaner now. Check it still works. List assignment index out of range. So yeah, that should be a dictionary now. Organism object has no attribute organs. Yes, it does. Does init mean this doesn't actually end up getting initialized? Or maybe that's what it means. Whatever, okay. Why does it keep... Copy that word there, nothing else. Organs. Okay, copied it. Now paste it. There we go. That. Okay. Okay. So we've got all organs related to one organism. We can try running our old algorithm and see if it still works, but there's going to be bits where the proteins like break. So don't worry about all this stuff. Just write all this stuff from scratch. So do we have any to-dos? Also avoid cells targeted by enemy. Yeah, that's don't grow in tentacles part. Yeah. So organism. we want some methods for organism, but like for example, wait, okay, so one of the things we want to do is work out our income. So look at all the harvesters, work out what they're fetching, and we'll know what our income is. Um, okay, so I mean that's straightforward enough. Should that be an organism method? No. Well, no, because organism doesn't know anything about the map. Okay, so let's say find, evaluate income. Alright, so we go through all our organisms. In each, we go through all our organs. All the harvesters, we or just when we're populating the organs, we can just look out for harvesters so that we don't have to search everything again. And if it's a harvester, we check if organ is a harvester, and I mean we know it's a harvester, but check if it's a harvester and add its income. So I need income, basically, my income. I guess we want enemy income as well. So for a given organ, it's not int, it's protein. Also, why am I using camel cases? I was supposed to change this. Let's change this now. It'll never get changed otherwise. Wait, why is the refactor not working? No refactorings available. What do you mean no refactorings available? Does that fix everything? Yeah, it does. Okay, fine. But isn't that what refactor should do? Okay, so change, rename symbol. Add income, so alright, so we find the target of the harvester. So if organ type is not equal to harvester, return. Okay, so it's a harvester. It has a target, so target equals organ dot pos plus organ dot direction. If self dot grid dot get, what happens if we try to get out of bounds? I don't know why we would ever put a harvester facing out of bounds, but if you don't account for these situations, then you'll just, you know, they'll come up. We have is in bounds, but I think we already... yeah, we don't want to get out of bounds. Okay, so if self dot grid dot is in bounds target and self dot grid dot get target equals And it's a protein. Then we add its vector, so it's going to be like a 1 in the A, 1 in the B, whatever. So it's going to be self.myIncome if organ.owner is 0, else self.enemy income plus equal the protein vector from that location. What's wrong with this? Expression cannot be assignment. Oh, no, that was right. Expression cannot be assignment. I see. Can I just do no? Oh, I see. Yeah, all right, I get it. So just say if organ.owner 0 else. So we know what our income is, but we haven't done anything with this yet. Okay, now we just need to okay, so now just add income. Every time we see a harvester, just add the income. So right, so if organ ID if type is harvester, say game.add income for this organ. Let's see if we can test that out. Self.myIncome log self.enemy income. So we should see the enemy income go up. Mine should just be 0. Well, this is wrong. My income 0, that's correct. Enemy income is 0 to begin with. Now it's 1. Oh wait, no, this is correct. Okay, it's correct so far. just realized I just realized something that's really obvious, and I never thought about it before. If you so each organism at most only needs to get one of each protein. After that, once you've got one of each protein, you never need more, do you? Because you can only ever make one organ at a time for that organism. But another organism may want to get one of each protein. Income should be localized to an organism. Okay, then. And look, the enemy's not even going for any more harvesters. He's just basically trying to cover the area, and that costs him fewer A proteins. And save the B and C. So Tentacle is the one that you may want to keep making. So B and C, that's what you want to get B and C for. D is used for harvesters, so you want to get D early on, just so that you can make more harvesters. But then once you've got one of everything, like what do you actually start with usually? Usually you start with enough to basically get. So harvester is B and C, right? No, C and D. And they've given us 6/6. That's enough to get one of everything, really. Yeah, he's saving his B and C for tentacles. Also, it's this tiebreaker. Is proteins, but that's not a big deal. We don't need to worry about tiebreakers right now. Okay. That's an important thing to note. Alright, so this income thing should really be localized to an organism, so okay, fine. So my income, enemy income, doesn't matter. It should be an organism-based income, and it doesn't matter who owns it as well. It's purely based on the organism, because ID numbers, I assume, are different for my organs and his organs. Like, yeah, we've got different ID numbers. Okay, so we just say income. It's gonna be a dict from int to protein. evaluate income. So whatever I did down here, we don't need to worry about. Just okay, so just populate everything. Well, evaluate income could be for a given organism, I suppose. Well, it'd be nice to have the enemy income as well, so... Okay, just say game.evaluate income. That's one of the first things we do. Alright, so evaluate income, it just goes through all the organisms. For organism in self.my organisms values plus the enemy ones, like just all of them. So go through all organisms. And basically we say for organ in organisms dot organs values. So for each organ, if organ dot organ type equals, basically it's just repeating this logic. I should have copied it. If it's a harvester, just get it back. Something like that. So if it's a harvester, target is that if it's inbounds and it's a protein, then we want to say, right, to start with, self.income of organism.root ID equals protein.0. Plus not supported for whatever. Pass that to a list. Is there like concatenate? Oh, I don't know how to use it. organism.organs.values, blah, blah, blah. Target is that. If it's inbounds and it's a member of protein, then must equal that. Okay. Now, let's try logging that. Log self.income. So this should just have the full table for every organism. So there should be 3 entries eventually. There we go. Yep, that's right. Alright, this is getting cleaner and cleaner now. So we've got income. Now we want to start putting together a basic decision-making process. So let's start with just seeking out the right things to harvest. So we want to harvest things we're missing, basically, for each organism. Now, like, arguably D is less important. Well, kind of need... You have enough D to begin with. But it would be nice to get it. Let's see what the boss is doing anyway. So the boss basically gets one of each, right? He gets... So he gets 1A and 1A. No Bs. No Cs on that one. 2 Bs. So overall he gets 2 Bs and 1 D, and he doesn't bother with C. Because I would think C is the most important one. Well, I would think the priority absolutely is to get A first. So for an organism, if you don't have A, you need to get A. Once you've got A, you got A, you need to get C or D. I would say C to begin with, because then you can do tentacles. So you got A, get whichever of C or D you don't have. Once you got both of them, then go for B. That's the priority. Make sure you have a supply of A, make sure you have a supply of C, then D, then B. Or get D if it's on the way, I don't know. So, I think there may be situations where attacking is the priority before harvesting. No, I don't know. I think harvesting is really very high priority. That once you've got an income, then you can actually start attacking. So we could do this in order, just start harvesting, then attacking, but I don't know. Now, we could just do a... So how did our BFS work again? We had... So the enemy never walks over proteins. But, I mean, I would say once you have an income of that protein, there's no reason not to walk over it, right? So we want to look at our income. Which things are we missing? Those things we're not allowed to grow onto, right? Those are the things we're going to harvest. If we already have an income for those things, then grow onto those things. That's fine, I think. So once we get an A, then you can walk over A's. I mean, that will give us the advantage over the enemy, because he's just kind of avoiding the proteins. But that doesn't serve any purpose. Also, he's sort of identified that I desperately need that A. So he's immediately, like, doing that. Yeah, that's pretty smart. Okay, so going back to my BFS, let's see how it worked again. BFS, it has a set of starts, which are my organs, a set of goals, which are, so we're going to specify which target we want to prioritize first. So if it's A, we go for A. If it's B, avoid will be all the things which we don't have income for. I think this will be a smart way of doing it, so we can... So, do we have to change anything in BFS itself? I think it's all fine. Yeah, we avoid things in the avoid set. We also want to avoid, like, dangerous locations where they got tentacles, but... we can worry about that later. And we're doing is growable, which lets us go over proteins, as long as they're not in the avoid set. Then we return... We return the closest one. Do we actually want to do that? Or do we want to just evaluate all of them and see which one's better? Well, the best one is actually the closest one right now, according to our method of scoring, because ignoring the fact that the enemy is there, you would just go for the closest one. I mean, this is a weird situation here where he stops us, but go for the closest viable one, because that's the minimum cost. You also need to look at how much B and C they give you, because if they don't, the harvester uses C and D. And if you run out of C and D, you won't be able to get more C and D. Well, you could roll, I suppose you could actually just grow into a C and D to get some. Yeah, I'm starting to think harvesting is not as big a deal as I thought it was. Well, harvesting for tentacles is pretty good. Harvesting B's and C's is good. D? I don't think you even want to harvest D. I mean, you could start sporing and making lots more organisms, I suppose you could do that, but... I'm not even sure you want to go for D. If you've got enough D to start with, you could make more harvesters. Well, your second organism won't be able to, but... I mean, what does he go for again? He gets 1 D, 2 Bs, and he doesn't bother with C. We start off with lots of C. But he doesn't even... He never attacks me, that's interesting. He's not really an aggressive boss, this one. He did when I tried to grow. For some reason he doesn't decide to just end me now. Alright, 1 second. So the idea is identify what targets we want. Oh man, how do I get started on this? Right, just start typing something. Okay, for a given organism, we want to seek out proteins we are missing. We'll do that for now, right? Priority A, and then whatever is used for making harvesters, I suppose. C and D, and B. Do it like that, right? So if self.income organism.root ID dot A is 0, then A is the absolute priority. So goal priority equals so I suppose we could do it like this: protein 1 0 0 0. So wait, no, what I don't know, like this. L if B is 0 or C is 0. This music's louder than it normally is. Hang on. Turn it down a bit. Down there. Okay. So B is 0 or C is 0, then priority equals basically either of these two proteins. L if self.income yeah, it's gonna be D. like that. And we can just say is an empty list. Right, so that's basically what we're saying. Why have I structured it like this? Well, I think if you change things later on, it might be useful to have it like in this form. I don't know. Well, it doesn't matter. So that's a list of the things we're prioritizing. So whatever proteins we seek out must be those. So we'll say goals equals P for P in self-dot proteins. If any P is greater or equal to, no, P, we'll say P equals, because I mean it's going to be equal. P equals I don't know, K for K in priority. So if it is, oh no, you can just say this. If this is the same as just saying if P in priority. So if we've got all the income, then there'll be no goals, so we won't actually seek anything out. Right? And if we can't find the thing we're looking for, like A or whatever, then we should just... Well, I don't know. Just don't do BFS then. Okay, so that's goals. Avoid. Basically just avoid anything which we need. Just do another big if else loop, it's fine. If A equals 0, hang on. What am I trying to say here? Did we do a greater than, less than? Add sub hash. We need a greater than. Define, well, less than. Basically, we want to say the full vector is strictly less than, so we want to say less. Yeah, but We want that, right? Less than or equal to, because hang on, let me just look this up. Oops. Yeah, okay. So if something's less than, we want turn self dot a is so less than or equal to other dot a, and self dot b but we also don't want it to be equal, so self is not equal to other. So that's less than, not less than or equal to. So if we say for each protein, if it's basically P for P in self dot proteins if that protein is not less than or equal to our income. If it's not, that means we need it. Less than or equal to. We need to define less than or equal to separately. Okay. Then we don't need less than, we just need less than or equal to. Take that one off. Yeah, that works. Okay, do that. Not supported for types pos and protein. Self-type proteins. Oh. If not, so it's maybe self dot maybe grid dot get p Okay, it's a bit confusing, but we're saying that if we are not exceeding that amount of protein, then we're avoiding running over that because we may need to harvest it. Do we avoid goals? We shouldn't. No, we do. Hang on, this is... Well... Alright, so the goals are not actually... the proteins themselves. The goals are the cells next to them. We need to change that. Yeah. So the goals, that's the goals we go to. Like, we want to go next to the proteins. We don't want to go to the proteins. So goals equals let's do this as a for loop. For p in self dot proteins, if it's a priority, for neighbor in self dot grid dot get neighbors of the goals dot add neighbor. Okay, do that then. And then we avoid the actual proteins themselves. Got it. Okay, so then BFS, it finds a path from the set of starts to the set of goals, which are next to the proteins, avoiding these spots, alright? And it will... And basically the next step you take. So if neighbor is in goals, temp equals neighbor, while came from temp 0, so this is going to terminate when we are one step before this is a bit tricky because you could be right next to a protein, but then there'd be no viable path. So temp will end up being the starting organ you grew from to begin with. Dist of came from temp is greater than... No, temp will end up being the cell we're going to place the harvester in. No, not even that. It's the next step we take. And then came from that will be the organ. Alright, so we say the next step. We should make a note of this. Turns. This will be the next step. Next step. Starting organ. And goal. Yeah, that's what we want. Okay, so now we want to run BFS. Also, we can move this to do here. So... if we don't find anything, we return none. So BFS result equals self.grid.bfs so it starts is just going to be organs, all the organs, I suppose. So it's going to be organism dot organs dot values. The goals and void will be a void. If BFS result is not none, then we've got next step. Right, so it's going to be like next step. That organ we go from, and target equals S results. I'll unpack that. And then there's two cases. Case one is if the next step happens to be the target, in which case we place a harvester. We don't know the direction either. Well, we didn't specify. Well, we didn't give the direction in the BFS result. We don't even know. We just know that was a goal space. That's fine, I guess. Okay, so if next step is not equal to target, that means we just grow into the next step with a A. If we'll say if self dot my protein dot my protein is greater or equal to protein 1 0 0 0. I don't have greater or equal to as well. Okay, we can do less than or equal to. If protein and protein less than or equal to. We do have that. We used it right there. Oh, we didn't run it. But don't we have it? Less than or equal to. That's what that means, isn't it? We'll run it and find out. If we can afford it, then we will do that. We'll say this basically. So it would be grow from hang on. So organ, this is going to be an organ pos. These are pauses. So this will be grid.get organ pos. Right, get the organ. We grow into that space. We want it to be a basic. And direction doesn't matter. Let's try running it. Okay, we're gonna have some problems now. String object is not attribute A. Oh. Get neighbors. What? What do I mean by get neighbors? Basically just anything that's inbounds, right? And it's not a wall. Return, I guess for safety we should be saying return is instance other protein. Yeah, you should always do that. Less than or equal to not supported between instances of protein and protein. But I... Right, I think we were fine doing less than before. Return, so to do less than or equal to individually, and then we say and self is not equal to other. It's strictly less than. And I think it puts those two together. Oh, why did I think it was lek? Didn't it used to be? I don't know. It's L-E. Plus organ and pause. We've got pause being an organ. What? Self dot get neighbors current. Current equals q dot pop left. So somehow we put organs on the queue. Oh. Oh, of course. Wait, this is just a list of organs. Damn it. That's gonna be... It's gonna be... O dot pause for O in. All right. So far that's correct. We build towards A, but we haven't put the bit where we actually grow the harvester. Okay. So we said if that, do that. Okay. else, the next step is the target, so we want to place the harvester. Make sure we've got enough for the harvester. If so, we want the harvester is 1-1 in C and D. The direction. We have to just do another search for directions. Say for neighbor in self.get self.grid.get neighbors of target if self.grid.get neighbor is a protein and it's in our priority, then direction equals neighbor minus target and break. One of those should be true. We shouldn't get a situation where direction has no value. Like, if we found a path here, then it must be next to a protein. So let me say self.grow target harvester direction equals direction. Possibly unbound. Yeah, we'll just hope it never happens. Hello, DJ. There goes the code. Well, I'm doing a major refactoring, so trying to write it all like nice and proper this time. I've yet to really run. Well, we're running it now, but we're only doing the most basic thing, which is seeking out proteins and harvesting them. I had to just comment out all this code down here. Alright, we do actually harvest it. Interesting. Alright, we are actually doing what I was expecting. Okay, why did we grow over a D there? So we've got an A, we've got a B, we've got a C. We need a D now. Why did we grow over the D and not try to harvest it? First time watching a coding stream, didn't know I would enjoy it. Welcome in, Garden Noob. Have you been doing have you been doing this? I think you were in here before, weren't you? Oh wait, were you in one of my game streams actually? Okay, we're actually doing mostly what I was expecting, except why do we grow onto that D? That's really strange. That's a bug. But we do target that D, so that's correct at least. Alright, let's think. So right now D, we've got A, B, and C. D is what we want. So priority should be that. Goals should... Alright, well let's just see what these sets look like now. Log goals log void. Let's just have a look and see if we've got the right things in the sets. Okay, so at this point, goals equals this. So basically every D on the map should be in these goals. But in particular, this one, 2, 0. Should be in there somewhere. 1, 0. Oh yeah, 1, 0 or 3, 0, but not 2, 1. So I was in your game stream 2 days ago, I guess. I stumbled upon one of your Advent of Code videos. Oh yeah. Okay. I'm glad you find it interesting. The site... Well, there's only like 2 days, 20 hours left, so there's a lot I want to do, but I don't know if I'll have time. So we've got the 1, 0 and 3, 0, basically, are the two goals. We do not want 2, 1. So just make sure we got... Whoa. Now this is wrong. Avoid is supposed to be positions, not proteins. Well, that's a flaw. Oh, that would be why. Ah, no, we don't do that. It's gonna be P. We avoid the position. Yeah, change that. That was the bug, I think. The void set was proteins, which made no sense. We're not avoiding proteins, we're avoiding positions on the grid. There we go. Now we efficiently get A, B, C, and D, while our enemy basically dominates the map. Baby steps. Alright, so... that is how we harvest everything we need. That's so much cleaner than what I did before. That whole thing there. Alright. So, phase 2. At this point we should just, like, if we haven't done anything else, just grow in some direction, right? So we want to say... we failed to harvest. Either there wasn't anything worth harvesting, or there was something worth harvesting but we couldn't afford to build towards it, or or whatever other reason stopped us from doing it, then we fall down to this piece of code here. Just grow in some arbitrary direction. Just do that. So let's say for organ in organism dot organs dot values for neighbor in self dot grid dot get neighbors for that organ's position. If grid dot is we need at least, we need to make sure we can afford it. If this basically. Okay, all that, blah blah blah. If grid dot is growable in that neighbor, we want to also make sure we don't want to overwrite something that we're harvesting. In fact, that should be the case here too. So when we evaluate income, we should also just keep track of like which cells we're harvesting. So enemy as well. Like, if enemy is harvesting something, then we should go for it. Steal their stuff. In fact, that should be a priority if we could spot something like that. Right. So my harvester does that. Enemy harvester does that. When we evaluate the income, say. Okay, just say if organ dot owner is 0, self dot, so that's going to be mine. Just pop this into set, so it'll be the target. One more positional. What do you mean one more positional? My harvested is a set of pause. Self.myharvester.add. That should work. I just test it. It's a set. I don't think it understands that that's a set. Expected an indented block. Yeah. Alright, it works. That's a weird error. Okay. Warning, not an error. So now we know what we are harvesting. We need to avoid those. So avoid, our avoid set is this. We don't need to. And then avoid, we want to combine it with union with self.myharvested. So don't yeah, it doesn't like these types thingies. All right, I think that should be fine. So now we don't specifically don't roll over any harvested things. Well, that was a problem. My harvested. What? We're trying to grow. Cannot grow in front of tentacle. Oh. Two, 4. Why are we trying to go there though? Why are we not going up? That's strange. Why did changing the avoid set? Are we avoiding? Okay, log these again. Have we avoided some of these cells for no real reason? So avoiding all these cells. Alright. Not that many. 1, 1. Wait, okay, so at this point, avoiding all of these cells. So we're avoiding 3, 4. Three, 4, okay. Correct. We're avoiding that because we're harvesting it. 1, 1. Yeah, because we need C, so we're avoiding 1, 1. 2, 0. Yeah. What about 2, 2? We shouldn't be avoiding that. No, we're not. So what's the problem? We keep trying to build in front of here. Why? Why are you trying to build there? Goals. So 3, 4 shouldn't be a goal now because we've got enough B. Two, 1, 1, 2. 2, 1, 1, 2. Yeah, these are goals. Okay, okay. 0, 1. Yeah, these are all goals. Cannot grow a basic. Oh! No, 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 no. That's the boss. So we can't grow at 2, 4. Why are we trying to go there? Oh. We're trying to build a harvester here, facing to the east. Well, that's wrong. 3, 4 shouldn't be a goal. Is it actually a goal? 3, 0, 3, 3. 3, 0, 3, 3. Sorry, 2, 4 shouldn't be a goal. Doesn't look like it. I mean, I can do a Control F here, but why would? So what are our goals? Our goals are basically C, right? B and C. Oh! I see the problem now. We're lumping B and C together, but if we do that, then we keep trying to go for B, even though we've already got B. So we don't act. So what we're really trying to say is, if it's If B and C are both 0, then we go for both of them together. Otherwise, we just go for... okay. Alright, I mean, this is a bit weird, but we could just do this. We can just say... if either of them are 0, then we'll go 1 or the other or both. We'll go for 1. So we'll go like, if... okay, so we just say... priority dot and then if C is 0, priority dot append 0, 1. So the idea is we stop going for B if we've already got B. But we do rank B and C as having roughly the same priority because we want them to do them before D. That's why I have to do it in this weird way. Otherwise they could have just done it if A, do A, if B, do B, if C, do C. But I don't want to say do B rather than C. I want to just, if we need B and C, and just go for whichever is quicker. Which, there's no real logic behind that. Maybe we should really go for whichever we have less of to start with. I don't know. Doesn't matter. Let's do it this way. Okay, so we go back to harvesting correctly. Alright. Alright, now we want to go back to this. Alright, so if it's growable and neighbor not in it's not something that we're harvesting, then just grow. So it's going to be organ dot hang on, so we grow from this organ, this neighbor, basic, return. Okay, now we should just grow arbitrarily once we've captured A, B, C, and D. There's still a problem with all this rigid do B, then C, then D, whatever. Because when things break up, and we can't quite get those things then... oh, look at that. That's cool. Better. Much better. I don't like the fact that we're going row by row, though, because that's just a natural consequence of the order in which we're traversing. We should try to randomize it a bit. I don't know. I don't like introducing randomness, though. It should be... we should prioritize... I don't know. We need a priority of things to grow in, but that's still better. The thing is, the boss is afraid to capture those proteins. I'm not afraid to. What's interesting is up here, if he just goes into DNC, that could harm me, but he, for whatever reason, he chooses not to. Well, he doesn't choose not to, it's just his code isn't smart enough to do that. Alright. Starting to see, like, the flaws in the AI that we could exploit. This is just the boss, though. Like, we don't want to tailor it to the boss, we just want it to be a good bot. Anyway. What we should do is just grow cells towards the enemy harvesting set. It seems like he has one organism for harvesting and one organism for, like, attacking. And there's so many places here I could attack him. No, I could, if I were to just attack, like, here or here, we would cut off some of his cells. I reckon what we do is we go for just make a beeline for the proteins that he's trying to harvest. Let's try that. That might be interesting. So we don't do this. Well, that could be the very last step. We can say, if all else fails, just grow in some arbitrary direction. Let's say grow towards enemy harvested. So basically do something like this. The FS results is going to be, so the starts is going to be that. Goals is going to be self.enemy harvested and void just avoid my harvested, I suppose. If we do that, then we do this. The only thing we care about is the next step and the organ pause. So just do that, and then say, I mean, okay, we need to be able to afford this, of course. Then we grow. Self.grid.get organ pause to that next step. basic. So let's try that. Ha! We ate his B and we ate his A. And we win. This boss is not protecting his proteins. That's how we beat this boss, but doesn't necessarily mean we'll beat everyone else in the ladder. Now, even better would be a tentacle. Not basic. But, I mean, that's a good start. And afterwards we just grow randomly. That's cool. Alright. Tentacles. If we put this in, this might actually be like a really good bot against the boss specifically. So okay, so we've at this point we've harvested things we need. Like tentacles is how much does a tentacle cost? It's B and C. We kind of need our C for harvesters, so sometimes we want to save C, but usually I would say if we have a tentacle opportunity, we should just do it immediately before even harvesting. Let's call that one Starve. Starve enemy, grow towards there. This one is just grow. I would say if we can see an opportunity to tentacle, then we should probably do it. Now the risk is that we waste C, which we need for harvest. So I would say always leave at least one C. Harvester needs C and D. Hang on. So why did I go for B and C? I did it wrong, hang on. We should be going for C and D before we go for B. Oh no, I did it because we want B and C for tentacles. Yeah, B and C is priority because we want to be able to tentacle. Okay. Tentacle. So I would say we basically create a list of all possible tentacle attacks, and then we can prioritize the ones that destroy the most enemy cells, but also the ones that cut off the most harvesters. That would be interesting. There's all kinds of things you can do, because if he's cutting off his A supply, that's even better. But now just target anything. So let's say candidates equals empty list. So for well, we're going to be able to afford it. So for tentacle, it's going to be B and C. Candidates equals empty list. Oh man, it's almost 3 hours already. I need to defrost my minced beef, you know. Candidates. Okay, so we go for... Okay, so we just do the same, like, loop that we do down here, where we look for this. Basically this loop. Okay, so for organ in organism.organ.values, neighbor, blah blah blah. So we call it neighbor 1. So yeah. Okay, so if it's not growable, continue. And now we want to see if there are any neighbors of this neighbor that are enemies. Okay. If self.grid.get neighbor 2 is instance organ and okay, if it's an organ, so target organ equals whatever that is. If target organ dot owner is 1, then candidate candidates.append. So we'll just put the cell we want to grow into. So it's going to be neighbor 1, and the target that will be damaged by it, because that's how we evaluate the score for doing it, like how much damage we do to the enemy, but also the direction, because we need the tentacle's direction. So it'll be neighbor 1 target organ. So after we do that, candidates may have a bunch of things. All right, now let's define a scoring system. Score for a given enemy organ. Return 0. Okay, for now, everything's equal. So we do, if there are any candidates, then best so then we say the position where we grow the tentacle and the target organ equals max amongst all the possible candidates, where key equals score. So we score key. Key equals lambda score of the second parameter, score of second parameter of the pair. Yeah, do it like that. Row pause target organ equals that. So and then we want to grow. So just do like something like this. So it's going to be we don't want the grow pause, we'd rather just have the... Oh, that's correct. Okay, so the organ was organ. The target location is grow pause. Type is tentacle. Direction equals, it's gonna be target organ dot pause minus grow pause. That's how we direct it. Organ is possibly unbound. Shouldn't be. Oh. Ah, okay, fine. Alright, just make it easy. Just say my organ. So we'll put my organ in there. Score on the target organ. So we got my organ, grow pause, target organ. The 3 pieces of the puzzle. My organ, grow pause, tentacle, target organ pause minus grow pause. Those are the 3 individual positions we need to make this work. And then we can change the scoring function. So now it should just, anytime it sees a possible tentacle to do it, it'll just do it. Hopefully, if we can afford it, of course. Well, that's interesting. We eat him. We absolutely eat him. So, okay, so... here, instead of... now, that's interesting. Do I actually want to do that? If I'm harvesting A, do I actually want to put a tentacle there? Against someone smart, I would say probably yes. Because if I don't, he will. It's like... it's a race to get there first. So I think that's correct, yeah. But the argument against it might be, okay, I'm harvesting this. I don't want to mess with it. But if I don't, he will, so... I guess it's okay to sacrifice it. Otherwise, he'll just do it himself, so... look at that, that's so cool. And if we can't afford a tentacle, we won't do that, and we'll just go back to trying to find B, C, and D. Yeah, that sort of works. Hang on. Okay, this is a bit strange though. So we've got income for A and B, and we want C. So we're going towards this, right? But why do we put a basic there? And not a harvester? So we are targeting C's, are we? So one of the goals should be 7-8. No, I don't see a 7-8. 8-7. Sure, I mean, you can do that. Seven, 8. Okay, fine. 7-8 is a goal. Why then do we put a basic and not a harvester? Oh, because we can't afford a harvester. Alright. So, basically, I would say, because Harvester and Tentacle both use C, we should only use a Tentacle if we have one extra spare. Change that to a 2. Or even 3. We need to always have enough to be able to make a harvester. Let me have a think. It really depends on how many more things we need. Okay, basically we look at our income, we look at how many things are missing, and we say for each of those things that are missing, we need one harvester's worth of income of C and D to be able to make those. And keep that as a reserve. So we'll say so up here we'll say it's not, we don't want it like that. We want it like alright, we do it like this. For protein val in, say, self dot my self dot income a no. What? How do we use this income thing again? This. Let's just say org income equals that, so we don't have to keep looking this up. So we say org income.a, org income.b, org income.c, org income.d. If protein val equals 0, so reserve equals protein dot 0. If you need a spare harvester for that income, then reserve plus equal protein 0, 0, 1, 1. That's how much it costs to create a harvester. And now we say if protein is going to be that plus a reserve, if we have enough for affording 1 tentacle plus reserve for all the remaining harvesting needed, then we do the tentacle. Let's try that now. We've got A and B. And the moment that... So they are harvesting A as well. But the moment we can afford a tentacle, i.e. we're keeping some reserve, 2 left. So now that we're harvesting C, we can afford it. So we can just say... do that. Huh. That's cool. Now let's just try this against some other seeds now. I want to see whether we actually get some wins here. Because that was just a very specialized case. See, they destroy us really quickly. And then we can't really do anything. Yeah, we're stuck, because we cannot get to A. So that's just a case of them cutting off. I mean, that's a good spore target. We need to think about how to spore. Like, big open maps are better for us. Tight quarters is where they can cut us off quickly, and we don't have any logic to deal with that. We win that one because we were protected from their sporing by the walls, which gave us enough time to out-economy them. No, different seed. So it's really just down to the map. I could just look at a map and say whether I'm going to win this or not, pretty much. Like, let's see. Okay, this map, I think we'll win this, because he can't do a quick spore. Ooh. Oh, that's interesting. So he just captures more area than us, but we are both kind of holding a stalemate. Every time we're close to each other, we end up doing that, creating a wall. So it's close. And the fact that he spored gave him, like... So once he gets A and B, he goes for the Sporer. So he goes to the Sporer and the Root, and that brings him down to 0D. But as long as he's got enough B and C to spare... Yeah, because he's got like 9C and 9B, so he can afford to do that, knowing that he can still get the C's and D's. He doesn't even bother getting C and D. Yeah, you know what? Maybe we shouldn't be going for D. Like, why do we go for D? D is for... harvester spores and roots, but if you're not going to do that anymore, then you don't need to. A, B, and C are the things you need to keep making. Maybe we just take out D for now. Don't bother getting D. Take that one out. Because you normally start with enough D to make the harvesters you need. That was worse, but I mean, it's sort of what we needed to do. Grabbed a bit of D there. The best spot here to go was that place, not that place. But that's a question of... We could have won this. Let's see if we can win this. Like, it's a question of having a good scoring system for where you put the tentacles, and we're not really doing that. I would say, for now, let's just target... Definitely put tentacles where... Return... Let's just return one if it's a harvester. Go on then. Return... int of enemy organ in self dot enemy... No. Enemy org, so int dot organ type equals harvester. Like, attack is harvesters. So that will prioritize those ones first. There we go. Oh, yeah. We win. Why do we win? Because he gets starved. But we also are trying to build there because we know that... Well, we don't know that that's an invalid spot to build. So... We need like a dangerous spot. Okay. But we win that one. So we need to be able to... Yeah, this is what we need. Avoid cells targeted by enemy. Also, here's an idea. Once we get enough income for tentacles, we should just be placing tentacles and not basic cells. Like, why not? It can only help, right? Those tentacles are guarding spaces. So instead of doing this, we can actually do a tentacle instead. If we can afford it. Let's just make a note here, I might forget. Okay. So we need danger spots. So we go for all the enemy organisms, or organ in organism dot organs dot values. We want to if organ dot organ type is tentacle, target equals organ dot pos plus organ dot direction, danger spots dot add, yeah, just add this. Even if it's not in the map, doesn't matter because this is just danger spots. Or organism. What? For organism in self.enemy organisms dot values. What's wrong with that? Oh, okay. If organ dot organ type what? I think this IntelliSense is getting confused. So it doesn't complain about that now. The organ type is tentacle, danger spots to add. Yeah, okay, whatever, do that. Let's see if that is okay. What? Cannot grow from ID equals 2. But I didn't change anything. We just made a set called danger spots. Not part of owned organisms. What? Cannot grow from ID. Oh. We're renaming this variable. Enemy organism. Yeah, keep this variable secure. Yeah, it's kind of bad to. Okay, fine. Okay. And now, void. All right. So when we do the tentacle thing. Neighbor 1 is where we would grow the cells. If neighbor 1 in danger spots continue, because we cannot build there. He will always kill us, even if we tried to out tentacle him. We can't. If his tentacle was there first, we cannot place something in its target. Alright, so that's that. And then harvest, avoid Avoid danger spots. And then down here we could probably do something. Starve enemy. We can use the same avoid set. That's a close one. Why are we growing like that? Why are we not? Because there's no path to the enemy harvesters. Alright. Alright. So we're now using the danger spots. So I reckon instead of growing towards enemy harvester, we just grow towards the enemy in general. So we say I think let's just do something like this out. So goals equals, I don't know, just like an empty set for now. Or you want to do this loop again, just say or for this. Right, for enemy organism and self blah, organ and blah, blah, for neighbor in self dots. In self dot grid dot get neighbors of organ. Pause. Goals dot add neighbor. Right, let's just find the closest cell to any organ, enemy and go towards it. Okay. And if we can afford... If we do that, if we can afford that, do that. No. If we can afford a tentacle, let's do that instead. It's gonna be like... keep forgetting. Tentacle is... BC. Then we'll do this. With what direction? We just say in the direction that we're growing right now. So next step. Direction is doesn't matter, but in some direction, just as a protection in case the enemy tries to grow there. I don't know. We actually want it to be an arbitrary direction because we're trying to defend against the enemy just attacking certain places, so... It should actually be left or right. So if we're growing in a certain direction, if we're putting tentacles here, they should actually look left or right. Just to protect against the enemy trying to tentacle our chain. Now let's just get a random direction. I don't know. Right, we'll just do it in the direction we're facing for now. Next step minus organ pause. Right. Doesn't really matter, but we can say base tentacle in perpendicular direction for protection. Alright, try that, man. We just grow towards the enemy, doesn't matter where, just somewhere. Try to attack him. We win this time. Let's have a look. Now we just start spamming tentacles. And the benefit of this is that because we placed a tentacle here and not a basic, then when he cuts down there, he cannot go there now. Because we preemptively placed this. Oh yeah, okay, in the direction of travel is actually good. Because look, we've protected this corner here. We've protected this spot here. Like, there's fewer angles of attack he can actually approach us from. That's awesome. Another one. So I don't think we even need to do this. I think the direction we're going is actually fine. Oh my god, we're trapped. That's a horrible seed. Ha! Oh, that's a horrible one. I don't even know what to do about that. Like, we have to really think, redo our logic for this. That's horrible. If we beat the boss most of the time, we'll still beat him overall, but that's a tricky seed to deal with. He's using spores, so... Ooh, we actually win that one, but it looked a bit fishy. Yeah, we basically cut him off. That is pretty cool. Alright, I think I'm ready to submit soon. All this crap we did before, we can now delete. I mean, that's not... We're not going to reuse any of that logic. It was a bit... It was like, do this, if this, do this, otherwise do this, otherwise do this. Like, now we're looking at a more of a priority-based... Yeah, we lose that one. Well, that's a tough one, and I can't even... See, we cut him off, but then we don't have as much area. But that's really because of his sporing. That's a tricky one. Are we ready to submit? Come on then. Try one more. We don't bother going for D. Yeah, that's a good one. Alright, submit. Completely different logic. It could be worse than before, who knows? Like, it looks good, but then I don't know how it will perform. Okay, we're getting good number of wins here. The other thing is sporing. Like, we've written our logic to deal with organism by organism, even though we've got one organism. So if we add another organism in the mix, this will work just fine. It will just, each organism will be independent. It will try to supply A, B, and C income for its needs, and then from that point on, it will just do its thing. So having a good spore target early on that's a complicated thing. And you need a whole different path finding algorithm to, like, considering that one move is like one straight segment for the sporing, then... Like, his sporing is interesting. He sort of... I don't think it's worth doing this. It seems like his first move is always to create a spore. Even if it's not a good move, I don't know. Alright, it's better than before, that's for sure. Oh, we got trapped. Oh, that's a horrible one. Yeah, we need better logic for what to do when we can't actually harvest, can't actually get to an A. We need to just grab some A's. But we shouldn't... No, we got straight up, got 0A. So what we should actually do in this scenario is... Yeah, that's a really nasty seed. These are very tricky situations they're putting us in, but... I don't know. I think when we find... When we find this thing, this path to the thing we want to harvest, we should also check if we can actually afford it. The thing is, I didn't want to do that because I felt like even if we can't afford it, we might as well start on it, and then maybe we'll capture some more proteins later on by another organism or whatever, but... Yeah. If we can't afford it, then what do? We just don't... We just grow arbitrarily. But that won't necessarily get us the A that we needed. It's It's a very tricky, and it's nothing to do with the enemy because it's just like our starting position. We're just trying to set up a protein network, but sometimes they put things in the way to make it confusing. We're in the top 10. We could actually still qualify it, because these situations where I'm losing are very obscure ones, so if it just happens like 1 in 5 times, then we'll still beat the boss. I mean, I think we are beating the boss when we run it against the boss. It's a question of whether we're, on average, beating everyone else. It's just how often these weird situations come up, and if there's a quick hack for solving them, I think a quick hack would be if you can't afford a path to the thing you're trying to harvest, then just grow arbitrarily. And the hopes are that might randomly get us the stuff. And it probably would a lot of the time. If we could just make it to 2nd place, then I think we will actually beat the boss. Because it looks like we do. Most of the time. That's a weird one. We're stuck in a deadlock here. I we kind of have to maintain that deadlock. Otherwise he'll gain on us. We do actually win though. Huh. So it's to our advantage to hold that deadlock there. The enemy literally can't do anything else. I mean, he can approach from this side, which is what he should do, really. But if he doesn't maintain this defense, then we'll kind of break in there and break him up. So yeah, I think he's in a bad situation there. And I guess that's why it's good to point your tentacle in the direction of travel, because then if they break this, they can't actually claim back that area there. We're still only 64%, so there's a chance that I might actually qualify. But we're starting to get losses now, so... 67 versus 65, I mean, it was very close. Why did it end? Oh, 100 turns. That's another thing. If it's close to 100 turns, we need to make moves which kind of take that into account, but it was still very close, so with a few more turns we would have outlasted him. We're hovering around the top, but not quite at the top. I guess we leave this till tomorrow. I've been going for like almost 4 hours now. Maybe overnight it will just promote. Like sometimes people above you will get promoted, and then that leaves you against the boss, and then you kind of end up beating the boss. So you can just end up promoting if you leave it for a while, but let's see. But in terms of pacing the boss, I think mostly beating him, but yeah, it's just these weird maps where, see that one, we basically destroy him. We're rank 1 right now. Is it stabilizing? We're getting lots of wins here. Might. Yeah, these small maps are kind of nasty. Also, there's a lot of more logic we can add to this scoring system for how we choose our enemy targets. Like, we should be picking the ones with like the biggest subtrees of cells that are relying on them, but also prioritize ones that are carrying tentacles and carrying harvesters. Like, it's expand this method, really. Like, we don't even... We'd rather go for a tentacle than a harvester, wouldn't we? Would we? Yeah, because harvesters... Like, by the time you reach the enemy, they've already got lots of backup protein, so the harvester's not important. We should really say tentacle. Win. Can we beat the boss? Seems like we do usually beat the boss when we face the boss, but yeah, these weird setups where we're like completely trapped. I guess. See, this is weird. How do we do this? We've got 6 A's, so we can go 1, 2, 3, 4, 5, 6, and then we can put harvester there. So I think when we're going for A, we should be not afraid to go over any of the proteins. You should just absolutely beeline for A's. He gets kind of trapped. What the heck's going on here? What's with all these spores? Like, he's very beatable. Let's see if we qualify. Otherwise, I think we should just change our void set so we don't actually... Looks like it's stabilized. Alright then. Let's do that. Let's say... Like, we lose this one, right? No, we win this one. Let's find one where we lose. Win that one. Let's find a really awkward setup where we get trapped at the start. Because we lose so many, loads of games we're losing are because of that. If we fix that, I think we're done. Yeah, look. Okay, this one. Let's resolve this one. So, we need to find A. Now we can't find a path to A. Wait. What? Oh, because we don't want to roll over D and so on. Okay. Let's change this. So, harvest. Like, going over proteins is not that harmful. You do at least get 3 proteins from them, so... Or harvest, alright. So, here, avoid. Avoid my harvested, correct. I would say the only thing we should avoid is... Not that. It should just be... self-dot proteins if P in priority. So it should just be the ones that we're trying to harvest. Those are the ones we should avoid dropping over. Try that. Only avoid the ones we're targeting. Roll over other ones, that's fine. So if we're going for A, we should be happy to roll over those Bs. There we go. And then we win, right? Yes. Again, I think that one change might actually have solved it. So now we won't get locked up at the start. That should probably cut out a lot of losses. I think this is it. Is my beef mince defrosted yet? I can keep going until it's defrosted. Oh, this one looks weird. Okay. One more, and then I'll submit. So we can stop logging. So they do an interesting spore there, but... Okay, we don't quite fight back. What was the problem here? We didn't really get our network set up before they started attacking us. But then... yeah, we probably... okay. Also, when we're building the tentacles... we aren't going to harvest these, so we don't actually need to do that. Let's see if that helps. We're reserving for A, B, and C, but not D. That didn't help. Okay, that was just a loss. Interesting. Alright, submit it. Let's go. Alright. So we're not getting any losses to begin with. That's good. That means we're not getting stupid losses where we just lose because... let's have a look at this one. Stalemate. Not much we can do there because we don't know. Our logic is not smart enough to know that he's going to keep putting it there. Yeah, he has a spare organism, so that organism can... yeah, that's an interesting one. But it's not a situation we can easily account for. Like we'd have to have memory. We'd have to look at the past few moves and say, okay, this has happened like 20 times already. Maybe we should try something else. But yeah, having another organism. Yeah, if we add a Spora, which we haven't done yet, then that would open up a whole different thing. Let's just wait and see what happens then. Alright, I'm not seeing as many losses, so... wait, what's going on here? Oh, we're out of A. Oh! This one is one where it forces you to need a Spora. So we're actually going to need... we actually need a specialized pathfinding for the opening to work out if we need a Spora or not. Because we cannot solve this on... you cannot get to A just by growing. It's impossible. You have to spore. So we kind of need a whole separate BFS which takes into account sporing. And it returns the next move we do. Alright, that'll be what we do next time then. Oof. Yeah, a bit of a stalemate there, but it was close. Alright, well, I'm just waiting then. Stop there soon. So, yeah. First phase will be to try and get A, B, and C. And it shouldn't be based on number of turns in BFS, but it should be on amount of protein spent, really. Well, not even that. Like, turns is actually the ideal. It should be only paths that we can afford, but you still go for the one with the minimum number of turns. So, growing a long way if we can afford creating a spore and then sporing across a large section and doing that, then do it. Yeah, that's how we gotta do it. So here, like, a better scoring system will be needed. We need to know that this is a better place to place a tentacle. It's nasty. Also, why did we go over A? No, we shouldn't have done that. Now that's bad. Let's have a look at this one. Why are we rolling over A? We're supposed to be targeting A. So... why are we doing that? We should be growing over here or something. A bug, so goals. So avoid my harvested and avoid danger spots. Okay, so it should just be avoid. Let's have a look down. The void is empty? The void is P for P in self-proteins, if P in priority. Sorry, what? Oh, I did it again. P is a pause. Be that. That's a bug. Or do I want to resubmit? We'll see if we get the rank. And then I'll resubmit. Okay, that's better. And we even win. Man. Do I submit now? That's a pretty nasty bug, but it looks like we might win. See if we can find any other issues. So we can't find a way to an A. What? How do you even get to A in this situation? Okay, how did he do it? Oh my god. That's even harder, because you need to make borers and... Oh my god. Borers and tentacles to get there. So we need to... Our pathing algorithm needs to take that into account. I mean, we could do that. We just need to keep track of what... we'll have at each stage, so yeah. We'll see if we pass. So yeah, definitely we needed to do here. Alright, we're getting lots of wins, come on. But we're above the boss. Just let it stabilize now. Yeah, that's nasty. Alright, we're whipping the boss. Alright, we did it. We're in gold. When we get to gold, let's just submit it because I've fixed this bug. And that will be it for today. We'll just find out what a final rank in gold is for today. Alright, gold league. First, that can't be right. That can't be right, that's a bug for sure. I'm not a legend. No, it was 688. Yeah, that's just bugged. Okay, fine. Okay, just submit it. And then we'll find out where we are. Now, realistically, I don't think I'm going to get to Legend. I don't have enough time with 2 days left. So I'm aiming just to get, I don't know, decent rank in gold. Also, now that we're here, I mean, most CodinGame participants that I know are in this league, I think. So, yeah, we're now pitting against our fellow streamers, viewers, or otherwise participants. Alright, let's see what's going on now. Still getting a decent rate of wins, so let's see where we end up. Interesting. We lost on the tiebreaker there. I mean, that's not something we really need to account for. Don't worry about tie-breaking. Let's try against... Against who? Who's around my rank right now, I think. It looks like he's got locked in. Oh? He broke out, but then my tentacles got him. Who's going for B's and D's? He's trying to gather all these proteins. Which is what I was originally doing, but and then I sort of felt that like you don't really need more than one of each. It would help as backup, but then what are you backing up against? I guess it really depends. Fresca. I don't know if we're climbing, I think we're just sort of probably around 450 we might get to. Okay, we're red. Ha! It's a deadlock. It's a... we lost on a tiebreaker. It's funny. Yeah, I don't know how to resolve deadlocks, because you don't... Like, this situation here, you don't know... This is very context-based. Like, you don't know that they're gonna go for that spot. Try a different seed. Interesting. So basically... we were going for C, because we kind of locked this one. Yeah, it's a bit weird. Yeah, sometimes you get these... He got A, B, and C like that, and I went for A first, and that locked out the C. Like, what you could do is try to construct a tree that hits A, B, and C. But... I don't know. Hello, British Rob TTV. BFS solves all. Yeah, it does. Although, if I were trying to branch into A, B, and C, I think that's no longer a problem for BFS. I think that's more some sort of greedy minimum spanning tree type thing, but I don't really want to go down that path. It could just be luck that he went for C, then A, then B, and that turned out to be... Let's try another seed. It's not easy to realize that taking that A would lock out the C, but... And we win that one. So this is nice and open. Nice open maps are easier to not soft lock in. Are you doing this competition, British Rob TTV? Alright, we're just waiting for this to stabilize, and that's it for today's stream. Looks like I might end up in the 400s. Cool. What is your username on the site? I could follow you. What am I searching for? Oh, yeah, yes. British Rob or something? Using Go to code mine so much faster for larger simulations in these games. I see. Yeah. Although right now we're not doing anything which needs like pruning. It's like everything we do, the full search is gonna finish within the 50 milliseconds, so... Alright. Rob G. Alright, so yeah, if you're in bronze and I'm in gold, then we can't actually put our bots against each other. Because it uses a different, like, server. But you will win. Or it doesn't let you if they're in a different league, because I think it's like... It's server-based, so all the gold people are in the same server. Also, with the wood leagues, it would matter because they have different rule sets, but yeah. I guess I'm not doing anything now. I don't need to actually wait for this to stabilize. We can assume it'll be in the 400s. Hello, Dahi Ninja. Stuck in mid-gold. It looks like a lot of these people are. I know, yeah. I just reached gold now, so we're basically doing a first submission and just see where I am and leave it till next time. Yeah, this my early game is definitely weak. I think my late game is good. I tend to be able to just destroy people with tentacles, but my early game, like searching for the right paths to the protein sources is really bad, especially if the map is small and tight. And sometimes you need tentacles or sporers to bridge the gap to the nearest A or whatever. Like, they literally don't give you enough A for it, which is cool. But speed equal, okay. Oh my god. It's nasty. Yeah. That's pretty crazy. Yeah, I don't know. I don't know what I can do for that one because the next A is over there and I mean, this is what sporing is supposed to be for. You want to probably spore, like, past the A before you start harvesting. Or, I mean, what is he doing? Yeah, he's sporing over the A and then walking over it, but then harvesting the other one. But he uses, he then walks over his A, but then he gets the other one. He's living like dangerously, but he's calculated it all. He knows how much A he has and how much it will cost to get to the next one and so on. Crazy. But there's spores and tentacles everywhere. Yeah. And if you try just writing simple code to push through proteins, it could harm you more than it helps you. Yeah, you need to be really smart, yeah. I mean, this is where you're getting into like pruning state space trees territory, where you're really pushing, searching to the limit and really looking at all the different kind of paths you could take. Alright, are we done? No, almost. 70%. Alright, have a look at this. Yeah, it's a small, tight one. Alright, well, at least it's doing what I would want it to do in this situation. Roll over the D to get to the A. But yeah, I mean, against the boss, the boss is we've established it. The boss is very good. Let's not fight the boss right now. Let's go with Coos. Interesting. So I sort of end up cutting down through there. Alright. Yeah, this one's not as bad because my code is already kind of ignoring D's and B's and C's to get to A's first. That's an interesting one. Very open map, that one. Oh wow, we actually win. It looked like I was losing at the start there. He's not defending his little organisms that much. Am I still the only one streaming? Looks like it. Let me have a look and see if anyone's actually doing it on Twitch. I mean, that thing might not be. Sometimes it doesn't always show me. Yeah, it is just me. All right. That last few percent. It's a bit slower here though, so maybe I don't need to wait. We'll just stop here. It looks like it's in the 300s. That's okay, that's pretty good. That's more than I was expecting. Being aggressive has sort of paid off in this case. There's some games, some competitions where being aggressive was usually just more, it would just basically exhaust your resources. This game, it's sort of deceptive. It seems like economy is very important, but it's actually not that important. Like, it's not like an RTS where you need to be getting more resources. Like, a single cell only costs one of each protein at most. So at the moment you have one harvester on each protein, you're self-supportive, and anything beyond that is like excess. So economy is not that important in this, at least in the first few moves. Building a path to the harvesters is the hardest part. So there have been games in the past where you don't really want to be aggressive because it harms your economy too much, but in this case it just costs you 1B and 1C so to build a tentacle, so but there have been games where you can get really far just by pretending the enemy is not there and just doing your own thing. This one's not one of those games. I only target max 2 of each B, C, D. No point having more. Yeah. I do one, but one for each organism. I do max 1 of A, B, and C. I say each organism. I've only got one organism still, but I might try going for more than one. But yeah, I go for max 1 A, B, and C, and the D I just ignore really. It seems like I usually have enough D. But I don't play with more than one organism, and you probably do need to, but you can get far on just one organism. It's just there's some weird situations, some maps where you absolutely have to spore to get to the A. Otherwise, you literally just exhaust and you're dead. You need to read the map and judge how much you have on your side. Yeah. So, yeah, I mean that'd be a good thing, but you get 1 second at the start for the first move. Yeah, you do. Yeah, that is, like, the best bots will usually use that full second to compute as much stuff as they can. I remember for the Pac-Man game, which was a couple of years back, that was one which was very heavy on the searching trees. So a lot of people were writing timeout. Once you get to almost a second, just stop pruning. That one was one where Python was really struggling with, because Python was at a huge disadvantage. You had to manually manage the garbage collection as well, because the auto garbage collection would just decide to destroy hash maps, at the worst times, and then you'd roll over your 15 milliseconds, so you had to kind of have pointers to keep that stuff in memory to stop the garbage collection from doing its thing. Yeah, Python is slow, but it really depends on the problem. And also you can use NumPy, which I don't normally do, but NumPy can do lots of stuff, which can be really fast. Alright, we're almost done. I think my frozen beef mince should be defrosted by now. Time to eat. It's just compiled C in the background that you can call from Python. Yeah. Ranking stabilization. What we got? Like it's around 390. I'm happy with that. That's pretty good. So far. Tomorrow I can... top Python person is in 11th. Oh, really? Yeah, I mean, if they're not searching big spaces a lot of the time, sometimes Python's not at a huge disadvantage in those cases. We've got 3 legends on Python. How many people are in the Legend League anyway? $25. Only 25 in the top league. With Amazon, I used to. That's yeah, still on my profile there. Alright then, I guess I'm done for today. I am starving. Tomorrow, we've got 2 days and a bit. Yeah, in the next couple of days I should be able to set aside some time. Like, one thing I really need to work on is the early game. Figuring out a better strategy for mapping out paths to harvest, and yeah, as you say, I can afford to use a lot more runtime, so it can be, it doesn't have to be a single breadth first search call, which is basically everything I've done so far. It can be like a multi-step one, where you build a path to one, then run another BFS from there, and then run another BFS from there. That's like basically a triple cubic BFS. Like, there might even be time to do that. And then see what ends up working. Yeah, because if you do that, alright, I don't need to think about that today. Think about it tomorrow. Alright. Thank you for the bits, British Rob. Yeah, today, well, that was 4.5 hours. And I won't even have time to go to the gym today. Yeah, well, coding game is more important. Yeah, that's it. Alright, thanks for watching. I will also upload this video to YouTube because apparently lots of people have actually found my coding game videos on YouTube and are apparently liking it, so I'll do that as well, but it's a big video, so it'll take longer to upload. And I will should be on tomorrow. If not, then the day after. Most likely both days. We'll see. Alright, thanks for watching. See you next time. Bye-bye.